Hello, and welcome for this new episode of Struck, our podcast where we talk about things that get us interested with builders from the StarkNet space. Today, I'm very pleased to receive Julien Niset from Argent. Hello, Julien.
Hey, Henri. Thanks for having me.
Thanks for coming. And you know, as usual, we'll talk a bit about who you are, what's your background, what stuff got you interested in the past, and what stuff are interesting you today. So, could you give us a short intro of of what you're doing today? What's your how would you define what you're doing today?
Sure. So I'm one of the three co-founders of Argent, which I started in 2017 with Itamar and Gerald. And so within Argent, I would say the one focusing more on everything related to the blockchain. I mean, of course, we are a blockchain company, so everything relates to the blockchain. But while Itamar is our CEO and Gerald and I we take care of the tech side, Gerald is a bit closer to the traditional tech. So working closely with backend, mobile clients, and I'm more responsible for everything related to blockchain. So smart contract, but also research, innovation, trying to understand, what new technology is coming, how that can impact Argent, on what we should focus on in the next 6 months and so on. So I would define my role as blockchain/innovation.
Cool. How many people are at Argent right now?
It's a very good question. We are between 35 and 40. It's a moving number as we've been growing the team quite fast recently. I think we should be around 38, I would say, 39.
That's impressive. Congrats.
Yeah, thank you.
So yeah, let's start. I'm curious to hear a bit more about your background story. So where are you from and what did you study initially?
Yeah, so I'm from Brussels in Belgium. I studied engineering, actually together with Itamar and Gerald, and I focused on physics. So I did engineering in physics. After university, I traveled for a year and then came back to Brussels to do a PhD. So I did a PhD in quantum information and quantum computation for 4 years, like theoretical physics. That was very interesting. After that, I did a postdoc in the US, so I was kind of a normal academic track, I would say. But
I mean, a normal, brilliant academic track, I would comment. But where in the US did you go?
So I did a postdoc at the City University of New York, and more specifically at Hunter's College, because I wanted to work with a professor there called Mark Hillary, which is a very creative person in the quantum information space. And so I really wanted to work with him. So I went there for a year. Yeah.
Can I ask, can you talk a bit more about this? What is, I'm not very familiar with what quantum information is or what, to be honest, I know in a very, very, very shallow sense what quantum computers are, but can you talk a bit more about what that is exactly? And you mentioned that this is theoretical. When we talk about quantum computers right now, it seems more like there are some applied projects. So, can you talk a bit about this?
Sure. So, I think the idea of quantum information, of quantum computing, emerged like at the beginning of the 90s. Because of Moore's law, we know that computer chips will become smaller and smaller, and so some physicists realized that if we're continuing to get smaller and smaller chips, at some point quantum effect would start to kick in. Because of course, if you look at the bit, for example, in the normal computer, it's actually a few millions, electrons stored somewhere in silicon. And so if you start to get smaller and smaller and smaller, then the actual quantum properties of these electrons would kick in. And so these crazy scientists started to think, what would happen if instead of encoding information on a million electrons, for example, in a transistor, we store information on a single electron using the quantum properties of that electron or that quantum particle. And so, of course, the first analogy is to imagine that instead of having a bit, you have what is called a quantum bit. And so you store information of one quantum properties of that quantum system. And if you think of an electron, it can be the spin of an electron. And when you actually go into that model, you realize that you open like a completely new space of research, because quantum systems behave completely differently than classical systems. And so you have a lot of new properties that emerge and that are typically not possible with a normal computer.
Wait, so you mean they're different because the spin of an electron has basically different properties than like a few thousand electrons, or because the way we manipulate them, or we could manipulate them, makes it different? Is it a physics matter or an engineering matter?
No, it's a physics matter. So quantum physics is radically different than classical physics. So if you think of the spin of an electron, you can imagine that it's in one position that you can call a 0. It can be in position that is a 1, but it can also be a superposition of these two states. So it can be 0 and 1 at the same time. While on a classical computer, either your electrons are stored somewhere or they are not. So your bit is either 0 or 1. With quantum mechanics, your qubits, they can be 0 and 1 at the same time. And so that actually enables a lot of new application. Another property of quantum, system is something called entanglement. And it's the idea that actually you can have two quantum systems that maybe are separated as you want, but you cannot describe and consider them as two separate systems. You need to consider them as a whole, because they exhibit some weird correlation. So if you do something on one of them, it has impact immediately on the other one, even though it's located at millions or hundreds of millions of kilometers. And
Is this the thing I heard about a few years ago when they say, somebody was able to use quantum entanglement to communicate over a large distance, and technically when you manipulate one, the other one moves immediately, and it moves faster than the speed of light?
Yeah, well, yes, but it's not. I mean, you cannot really use that to communicate, but you can use that properties exactly to do a lot of cool things. And for examples, one of the first things these researchers came out with is the idea of quantum teleportation, because you can have your system with one component, one part of your system on Earth and the other one, say, on the moon, but they're still part of the same system. And so if you mix the system with a quantum system on Earth in a certain way, actually you can teleport the state of your initial quantum system from Earth to the moon almost immediately. And so, I mean, they came up with the idea of quantum teleportation. Of course, people got really excited. It's not real teleportation, but it was like a way to show that you can do new stuff. Again, using quantum system, you can do something like quantum key distribution that people usually call quantum cryptography. And again, because you are leveraging properties of quantum system, and in that case, you're using the fact that if you measure a quantum system, you force him to collapse onto some fixed state. So you basically disturb that system. And so if you use quantum system from point A to B, from between Alice and Eve, actually, if someone is trying to eavesdrop, you can detect that someone is trying to eavesdrop, because it will taint the receive quantum systems, if you want. So anyway, so using these properties of quantum mechanics and applying that to information, there's a lot of new stuff that can be done. And of course, people are now trying to use and to harness these properties to build quantum computers.
And how much of it is theoretical? How much of it is applied, would you say?
So there's actually, I mean, it's the problem with quantum system is that of course, it's very difficult to isolate them from the outside world. And so if you think of the spin of, if you encode information on the speed of an electron or like on a two-level system atom, the surrounding environment, the other atoms, the other particle will of course influence that state. And so that means that your quantum state degrades very, very rapidly, or it's called the decohere, very, very rapidly. And so the main difficulty from an engineering point of view is that it's very hard to keep your system without interaction from the outside world. So there's a lot of stuff that have been predicted from theory. But of course, to engineer that is taking a lot of time. I mean, the field started in the 90s. We are more than 30 years later, and we can still do very limited computation using a quantum computer. But I think it was probably the same with computers, if you think of them. I mean, it takes time, but at some point we will harness these quantum properties. And I think we are close from reaching a point where some quantum computers can do stuff that classical computers cannot. So I think we are really approaching the moment where actually quantum computer will start to be useful and do stuff that are not possible on a classical computer.
That's fascinating. And so during your PhD, after your PhD in Brussels, you went to the US. Did you work on the engineering part or the theoretical part?
No, I'm a pure theoretician. So I really worked on theory. And I focus more actually on this entanglement properties, which I find it very fascinating. And so I naively wanted to better understand it, because we still don't really understand, why and how. Well, we understand how, but we don't understand why. So I really wanted to dig into that. But that was already a long time ago.
Nice. So what happened after that?
So after that, actually, my thesis advisor offered me to come back to Belgium and work on a startup project in collaboration with the university. So in the lab in which I did my PhD, we developed some intellectual property, and the idea was to see if we could actually build a company out of that. And so he asked me and another ex-PhD student, Louis from Canada, to come back to Belgium and actually work on that project together with the university, which I did, I think, for 4 years. And there, the idea was to use quantum physics, actually the quantum properties of a laser, to generate the true random numbers. And using a setup that we had designed in the lab, we could actually generate like thousands more quantum random numbers than anybody else. And so the idea was to build a quantum random number generator and to try to commercialize that. So that was very, very interesting. But you take a bunch of physicists, you put them, in a room, and you say make a company out of that. You make, of course, a lot of mistakes. So we did develop a really cool technology, but we really struggled to actually raise enough funds to productize or prototype.
Is there a lot of demand for quantum random numbers? It seems like a very, very, very small field.
I would say yes and no. It's clearly no, but I think people underestimate the risk of randomness, because randomness is everywhere. If you think of security or cryptography, you need random numbers. I mean, every time you connect to your Gmail account or you use SSL, there's actually random numbers being used, and these random numbers need to be generated at some point. And if they are not properly random, then an attacker can actually crack the security. So it's actually very important that these random numbers are really random. And computers, they're deterministic by design. So it's impossible to produce true randomness with a classical computer. And so there's a bunch of hacks, a bunch of ways to try to do that. But there's no theoretically secure way to do that with a classical computer. Of course, it's always a matter of trade-off. I think there's more urgent, security problems. If you think of data centers, for example, they have bigger problem that the randomness they generate in their server, and that's probably why we struggle to convince them to buy our appliance. But randomness is very important, and I think gradually, it depends on the type of application. I think for high application with high security, it is needed. And so, for example, one of our competitor, which ended up acquiring our patents, is a successful company because they focus a lot on banks. Of course, in Switzerland, there's a lot of banks, and for them, security is very important.
I was going to say the military. Also
exactly,
seems like
the military and the financial. Yes, military and financial, market are in need of good random numbers, and they're willing to pay the price. But of course, it's still a very niche product, and that's probably one of the reasons we never managed to to sell an appliance. But anyway,
sounds like an interesting experience.
It was an interesting experience. I learned a lot. It helped me, transition from a pure academical researcher to a bit more of an entrepreneur, which is something that has always interested me. So after that experience, my associate Louis and myself, we were hired by a company in Silicon Valley doing M2M and IoT. It's basically the only company that was excited about our product and that wanted to buy and resell our product for us in the US. And so when we told them, we're shutting the project down, we're selling the IP and we're going to move to something else, he said, "Oh no, come work for me." And so for I think 2 or 3 years, I worked for that company called M2MI, for machine to machine intelligence, which was one of the pioneers in M2M and IoT, and was really focusing on the security aspect of it, which was a natural transition from our previous startup, which, even though it was quantum, it was very close to security and cryptography. So
it's really interesting because the thread that comes in all of your experience seems like is security, right? Like,
yes.
and the need for like a secure and sound mechanism to secure stuff.
Yeah, definitely. And I think that's why gradually led me to blockchain after that experience. So
how did you hear about the blockchain?
That's an interesting story. I think I heard about Bitcoin very, very early. I would say 2009 probably, by another PhD in the lab, who showed me that technology, was really excited and showed me, he could buy Bitcoin on an exchange and then he could use it to buy hardware. And so he showed me all this, and I was like, this is not, this is really too geeky. This will never work. Never be interesting for mainstream users. So I completely disregarded that. Few years later, another friend tells me about this new blockchain called Ethereum. It's very interesting. He sends me the website. I have a look, and I'm still, this is way too nerdy. This will never work. So I passed again.
You discarded it not because of technical reason, but because of product market fit, or because nobody would use it?
I think probably out of laziness, in the sense that I never dig into it. I read the homepage a little bit. I was like, okay, this is maybe interesting, but this is too complex, and I don't really see a need for that. I'm sure if I dig into the technology, it would have gotten me excited. And this is, in the end, what I did in 2017. This time it was Gerald, so my now co-founder, that started to be a bit interesting about that. We used to work sharing a co-working space, but working on 2 different projects. And so we exchanged like technical articles, stuff about technology that excited us. And so he was the first one that brought something about blockchain. And because it was for him, I thought, okay, maybe it's worth a read. So I started reading a little bit, and then realized that it was indeed a very, very interesting technology. But started to be excited about the technology. First, more than the use case. I thought it was, fascinating the way this, blockchain worked. And so that was in 2017. And so we got, him and myself more and more excited, started to read more, to get a bit more into it. And then at some point we told Itamar, we need to do something in that field.
And also 2017 was, there was a big spike of price, obviously, but interest also. I remember that, the months leading up to the end of 2017, there were more and more articles, and a lot of more people started paying attention, saying, oh, you could do this, you could do that. And so it creates some kind of emulation, I imagine.
Yeah, definitely. And there were, I think at that point, there were people starting to build like real application. So moving away from just pure payment or the core protocol, but starting to think about, how to use blockchain to track assets, or how to, all these ideas. And so I think I started to see the application side of it. But anyway, so that got us really excited. I think another aspect that got us 3 excited is that even though we are old for the blockchain, we were a bit too young for, the .com era of the beginning of the year 2000. And so even though we've been doing startup, we kind of felt that, this blockchain technology was a wave that would, take the world over, and we wanted to be at the forefront of that wave. So we kind of felt, this is like, the era of the internet in the year 2000. Whatever we do, we need to do something in that field, because
this is our time.
Exactly. And so that's literally how we started with Argent. It's like, let's do something and then see where it takes us. It happens that thing is still what we are building now, and actually our product or our vision hasn't changed at all. But the initial motivation was to just do something in that area.
Why did you start to like focus on wallets? Why wallets? Why smart contract wallets? Because how would you define we didn't talk about that. How would you define in a few words what Argent does?
Yeah, Argent is a smart contract wallet. I think it's a smart wallet. The idea of Argent is to bake like the flows and the security mechanism that users are expecting. Sorry, but in a fully non-custodial way. So I think if you consider how we normal users access to to our email or to a bank, we expect certain properties. We expect that we can lose a password. We expect that if we do something that is malicious, our system will tell us you're about to do something very stupid. So there's all these security mechanisms that are baked in the financial system today or the internet that user expects. But they are actually very hard to do in a non-custodial way. So the goal of Argent is to really enable this normal user experience on blockchain, but in a fully non-custodial way. But to come back to your initial question, why did we start focusing on wallet? I think at first we started looking at application, and Itamar and Gerald, my two co-founders, they come from a very consumer market. Before Argent, they were building an application called Peak, a mobile application, which was like the leading brain training application on iOS and Android. I think they had like 60 million downloads. Yeah, brain training. So basically, it's a bunch of small games that you can do every day, and that improves your cognitive performances.
Nice.
And so they had like a very big product, and so they were really consumer focused. So we started looking at application. But of course, doing so, we realized that there was, even if we were building a good application, there was no good way to connect to that application. There were like people working on the protocol and like hardcore, low-level stuff. And then there were people dreaming about this application of blockchain, but the way to interact with it was completely clumsy and broken. I mean, if you come from outside of blockchain, and for me, for example, coming from a bit of a security background, the idea that you need to back up a seed phrase is terrible. If you think of the internet, I mean, that's what I said to Itamar and Gerald early on. On the internet, we've spent like the last 40 years trying to convince someone like my mother not to write a password on a piece of paper. And now we are building a financial internet. And the first thing you are supposed to do is write that password on a piece of paper, but not once. You're supposed to write it 2 or 3 times in case one of the papers, disappears or gets burned down. I mean, this does not make sense.
I remember a story about the founder of French Exchange, who, they had a hot wallet and cold wallet, and like most exchanges, 95 or 90% of the funds are in cold wallet. But when the hot wallet started to be drained by users or like just the normal course of operation, the CEO would take a taxi and hit a few safe points, like at banks in Paris, to retrieve some private keys written on a piece of paper, which is super fun when you think about it. Like it's the future of money, digital money, but we still save it in safes at local places.
And I mean, for a company, it may still be okay, but if you want to reach normal users, we don't have a safe. We don't. I mean, and so we realized that there was all these friction point, like the way to interact with these future to be blockchain application literally made no sense. And so we said, there's a big gap there. Let's build a wallet that is non-custodial, that is secure, but that someone without a PhD in cryptography, without a computer background can actually use to interact with that emerging technology. And so that's how we identified that we wanted to focus on wallet. And so we locked ourselves together in a room for 2 days, like I've said that before, but very cliche. We had like Post-it and markers, and we tried to come up with all these ideas that we had. And so we started to put all these Post-it on the wall, and gradually combining all these things, we started to realize that there was a product there. For example, people were starting to talk about ENS. It was still very, very early, but we realized that ENS could be a bit like a weak form of identity. And that could be a good way to get rid of long hexadecimal strings that are bound to help you make a mistake. And so we said, okay, we can use, this ENS. Maybe it can be a bit like email. It can be a way to or an IBAN. It can be a way to identify your account. That's already one way to remove a bit of that friction. Another thing that we identify is that people were already talking about ETH2. And we said, okay, actually, this staking, it can be a way to have some kind of a savings account. So maybe you can have some financial primitive on your account. You can have your coins, but maybe you can stake them and a bit like a savings account in a normal bank. And so we collected all these ideas together, and that started to give the vision of what Argent is today. And yes, and then there was for us, there were two more blockers. There were hexadecimal string, which are impossible to use for normal person without making mistake. There was the problem of the seed phrase. That was our problem number one. We thought that it made no sense to have seed phrases. And then there was the gas. We thought that gas was very complicated to understand. As a first user, there's all these concepts that you need to understand. And so we started thinking, how can we crack these problems? And so we started focusing first on the problem of seed phrase. And I think at that point, there was a paper from, I think, Emir Gunsirer, which is now the founder of Avalanche, but he was talking about some kind of a Bitcoin vault where you could have different keys and so on. And so reading that and discussing about it, we came up with the idea of the guardian mechanism on Argent, social recovery, and so on. So what we identify, I think, is that for us, the only way to crack this user experience was to use a smart contract. It will never work out of a seed phrase. If you have a seed phrase, a single secret, either you keep it at all costs and the majority of users will make mistake or lose it, or people will delegate that responsibility to someone else. And then you end up in a custodial world, which is not much different than the financial system today. So we kind of felt that the only solution was to use a smart contract to solve that.
I've seen some debates recently around a concept called MPC or multi-party computation, like our threshold signatures. Is it something you guys considered, and or not really, or was the research not there at the time?
So at the time, I would say the research wasn't there. Today, I think it's a much more mature technology, and MPC is an interesting technology. That's something that we've debated before and that we are still debating. I feel that in most cases, it's more prone to censorship resistance issue than our model, but it has some benefits as well. And one clear benefit is that in the end, you have just one identity. So you're still in that EOA model in a sense, and so it's much simpler in a purely multi-chain world, because you can bring your identity, because it's just a signer key. You can bring your identity on multiple chains, which is more complicated to do with smart contract. But on the other hand, I do believe smart contracts are much more powerful because they enable much more flexibility. And they are much better in terms of, I think, ultimate censorship resistance.
You can't have you mentioned staking and having a sort of saving account. You can implement this kind of features or in a smart contract, or I don't know, time delays when you lose your keys, this kind of stuff. You can't really do that with an MPC, right?
Exactly.
It's not like you can't combine an MPC with a smart wallet, right?
That you could do, and that's something that we are researching. You could use an MPC as one of the signer in your smart contract. And so I do think it's not a one or the other technology. The best solution is maybe by combining both. But we strongly believe that the proper foundation is a smart contract wallet. And that we are still very, convinced about that.
How did you start? Why did you choose Ethereum rather than any other chain? 2017, there were a bunch of other platforms launching. Some of them you could use at the time. What made you stick with Ethereum?
It's a good question. I think from our point of view, at that time, we really only considered Bitcoin and Ethereum. I think these were clearly the main ones. There were people working on, Alt-L1s and other chains, but clearly Bitcoin and Ethereum were the most important ones. And from an I mean, Bitcoin did not have the programmability that we needed for our model. So it was a no-brainer that, it needed to be a chain with smart contract. And Ethereum at that time was the natural choice. A lot of people questioned us, saying, why are you not going there? Why are you not doing this? And we always felt that Ethereum was like the best ecosystem for what we wanted to build. And so it was more or less of an easy decision.
Yeah, for sure. I understand what you mean. Like technological features are important, but what we're building are essentially networks, which are like both technological and a matter of who's there and how many people are there. And so how many people use the network is uh, at least as much important as the technology. I don't know if you can really compare both, but both are extremely important, I think.
Yeah, definitely. And the amount of developers building and the community is thriving and so on. All this is very important to in the end make the best to choose the best platform. So yeah, Ethereum for us has always been our number one choice.
Very nice. And Argent right now is so it's a smart wallet, but it's also like it very quickly turned into a web app, right?
What do you mean by a web app?
No, I'm sorry. I remember installing it on my phone like since the beginning, more or less, right? It
Yes.
never just was a smart contract or some kind of.
Oh no,
like
of course,
user
yes.
experience was always super lean from the beginning.
Yes, it's not a protocol in a sense. We are an application for users, and users are front and center in everything we do. I mean, what we wanted to crack what we wanted to make is to build a product that users will use, to build a wallet that billions of users could use to access the blockchain. And again, for us, mobile was the natural choice, even though, I mean, clearly MetaMask has much more market share than we have. And today, the majority of people are still using browser to access blockchain. It was clear for us that the future was on mobile, and we still believe the future is on mobile. Of course, there are benefits of using a browser extension, for example, today. But for us, it's a no-brainer that wallet should be in a phone. And again, it relates to security. The way we see is that your phone is your remote control. It's really that's the device that you keep in your pocket at all times. That's the best way to actually secure your identity, your asset, and so on. So for us, it's natural that this remote control, this access point, is on the phone, on your pocket, and you should leverage the security that's available there. So our vision is still to build a mobile wallet. But of course, as you know, on StarkNet, we've experimented with a browser application, which turns out to be a good experiment. And we are building Argent X as a browser extension. But the way we see it now, even if we still feel the future is mobile, browser extension are relevant today. Because, of course, we are still experimenting and there's a lot of things that needs to be done. And there are certain applications that can only be properly accessed through a browser.
So by now you have like you mentioned Argent X and you mentioned Argent. So you've had the experiment, like reframing my question a little bit. There's a lot of talks about censorship resistance and how we're subject to, censorship from cloud operators or GitHub or what have you. One of the first steps between you and consumer is actually like app stores or extension stores. You've had the experience of pushing applications both through app stores on iPhone, on Android, and through an extension store like the Chrome extension store. How's that process? I know that some applications have had a lot of difficulties saying, yes, we're a wallet, you can exchange or manipulate cryptocurrencies through our app, and they've had difficulties being listed. Was that your experience? How was that process?
No, I think it always worked quite well for us. Probably one of the reasons is that my two co-founders, Itamar and Gerald, as I mentioned, they had a very prominent consumer product mobile brain training application, and so they had a very close relationship with Apple, for example. And so
nice.
they know Apple, they knew Apple quite well. It's not like we leveraged that, but they knew exactly what you could and couldn't do on the App Store. And I think a lot of people are a bit too naive in a sense. And so I think we've always been good at navigating what exactly is okay on the App Store and what is not. And so far, it's always been easy for us to submit our application. By the way, talking about censorship resistance, I think something which I find very interesting about the smart contract model, and again, Argent, is that from day one, we've always assumed that we could disappear as a company. And again, that's something that has always been very important, because we know you can be censored in many places. You can be censored by Apple, as you mentioned, but you could also be censored by us as a company, or if on StarkNet, you could imagine being censored by Starkware at some point. So in our product, we've always focused on making sure that even if everybody disappears, users still have the ultimate control. And that's something that we've always baked into our product. And that's why a smart contract, makes sense, because your smart contract is there. Maybe you've lost, the gateway to that, which is your mobile application or your browser extension, but there's still a smart contract which still has some rules. And so provided that you control certain elements, you can always update that product and have true ownership.
You always have a safe escape hatch to get back to your assets, right?
Yes. For example, nice. An example of that that a lot of people don't know, but on Argent Vault on L1, of course, we were using a system of relayers, and then we go through Infura and so on. And so we didn't want this to be a single point of failure. So today on Argent, on the mobile application, if you want to do a transaction and you long press on send, instead of sending the transaction to our backend, to a relayer, which will then ping Infura, it actually produces the data of the code. So you can do cut and paste, and you can paste that into your MetaMask if you want, and execute that transaction without going to Argent. So there's all these kind of things that we've always built in our technology to make sure that the users truly have control of their assets.
That's really interesting. And I think there's a counterpoint also to, not a counterpart, but like another focus on that. And I saw Patrick McCory mention it on Twitter recently. There's the side that this is beneficial for a user, because if you guys ever have to censor, or if anything goes wrong at some point, they are in control of their asset. But it's also something good for you as a company, because it removes a liability, right? If you don't manipulate funds, this is like you sleep better at night.
Definitely. Having written the smart contract of the Argent Vault, sometimes it's a bit stressful, because it's a smart contract. But right, from a company point of view, yes, in terms of regulation, it is much simpler. I think a good example of that is that early on, we started experimenting with multi-call, or the ability, because you are a smart contract, you can orchestrate calls on the blockchain. And so, for example, we orchestrate interaction with DeFi protocol. And so we integrated Compound very rapidly. It literally took us 2 weeks to integrate Compound. That was like 2 or 3 years ago. And I think Coinbase tried to do that and release a similar product almost 2 years after us, and they got destroyed by regulation. Of course, they are Coinbase and not Argent, so the regulator is looking at them differently than at us. But I do believe that being purely non-custodial enables you to innovate and move much faster, because you are less prone to all these regulations that centralized exchange have. So I think that's also one clear benefit of self-custody. I mean, we believe in self-custody for I wouldn't say political or philosophical reason, but because of what it brings. But I also think that there's a true benefit in terms of innovation, because it enables you to move much faster than if you are custodial.
Interesting. So you mentioned Argent X a bit earlier. In the past few months, maybe in the past year, maybe even, you guys started expanding to L2s. Can you talk a bit more about how you got interested into L2s in general, and what was the process, the discovery? What made you think maybe it's worth expanding beyond Ethereum, if you consider L2s being beyond Ethereum, or you can also consider them being part of Ethereum?
But, I personally see them as being part of the Ethereum ecosystem. So it's for us, it's very different to build on StarkNet than to build on Avalanche, or on or on Solana. So yeah, for us, it's part of the same ecosystem. But yes, I think so. One thing that I mentioned is the idea to abstract gas. And of course, for those who've been using Argent for a long time, you remember that we used to subsidize transaction because again, we believe that this needed to be extracted to the user. And our assumption was that transaction fee would go down. And for us, it was a no-brainer because if transaction fees were not going down, then the ecosystem would never work. In the sense, it would still remain a niche product, this blockchain. So for us, if you wanted to reach mainstream usage of blockchain, it was a no-brainer that transaction fees had to go down such that making an action on the blockchain would cost you less than 5 or 10 cents. But so, of course, this turned out to be a bit more complicated than that because, between then and the future, it will be low. There has been a crazy spike in between. And so Argent started to become, transacting on Ethereum started to become very, very expensive, but even more so if you're a smart contract wallet, because of course you have a bunch of logic to secure your assets, and this logic has a cost. Every time you make a transaction, there's some compute that is made to make sure that your transaction is secure, and this has a cost. And if transaction fees are low, this added cost is negligible. If transaction fees are crazy, well, it makes transacting with Argent even crazier than with a MetaMask, for example. And so it started to be clear that the future of our model was not on L1, probably. It needed to be on something that was cheaper, but still had the same security guarantees at Ethereum, and that is layer 2s that people were building. And so we started to investigate and research layer 2s early on, and discuss with all the partners. I think we've been friends with Starkware for several years now. But so we were kind of researching what would be the right technology for us and the right home to focus at first on our L2 effort. And I don't think we framed it as clearly back then, but for us, it needed to scale transaction, to make transaction cheap while maintaining the security properties of Ethereum. And so we identify rollups, and more specifically ZK rollups. And also today, what we know also is that we need to scale the user experience of security, i.e., enable the model that we've been pushing at Argent with smart contract. And for that, account abstraction is the right way to do so because it bakes our model at the protocol level. And so all this to say that we identify Starkware and ZK Sync as the two best new home for Argent in a sense. That doesn't mean that we are not considering other rollups. We are good friends with Optimism, Arbitrum. There's other ZK rollups emerging. So there's a lot of people doing a lot of good stuff. But of course, we cannot be everywhere all the time. And so we wanted to focus our energy on providing that ultimate experience that we've been dreaming for 4 years on one or two chains, and decided that these two chains would be StarkNet and ZK Sync.
How did you? So when you started considering StarkNet, there's obviously one big thing in the middle, which is Cairo, right? So how did you see that in the beginning? Was it like no, not a problem? Was it something where you thought, this is complicated? How did you get familiar with Cairo yourself? Because you do most of the development in the R&D, right?
Yes, yeah. So we knew that ZK Sync v2 and StarkNet would be our new home. Before that, on Starkware there was StarkX, which is a great technology, but it's more of a vertical application. We didn't feel like a wallet made sense for StarkX as our position has actually changed with respect to that. So I do think there's value to having a good wallet across different StarkX instances, but that's another topic for discussion. But so there was StarkX and there was ZK Sync v1. We experimented a bit of both. We decided to do a first proof of concept of our model on L2 on ZK Sync v1, as you know. But of course, we were waiting for ZK Sync v2 because we wanted to have smart contract, availability. So we're waiting for ZK Sync v2 and StarkNet. And so I was monitoring both in parallel, and actually StarkNet was more ready to experiment with, because zk-sync v2, they were like delaying giving availability to, writing smart contract and Solidity and the testnet. And I do think StarkNet took a very interesting approach, which is to release something early, which was very bare bone, but actually build on top of it with the community, which I think was an amazing strategy. But so I would say in early December, end of November, I wanted to write a smart contract on one of the two L2s, and only
December 2021.
Yes, so that was like
a bit less than a year ago. Yeah.
Yes, exactly. And so it was not possible on zk-sync v2. So I was like, okay, I've been monitoring StarkNet from the side. I'll dig into it a little bit more and see, how mature is the technology, where it's at. And so at first I joined your Discord. I was, looking at message, interacting in discussion. It was funny because I think back then there was like few, maybe 50 people really talking on Discord or developing stuff. It was still a very small ecosystem. And again, the same thing that we noticed in a sense with Ethereum is that there was a big gap. There were, of course, Starkware building StarkNet, and then there were these dApp developers thinking about their dApp, how they could leverage, what StarkNet is offering to build new experience in gaming and other areas. But then they were all, how do we connect to the protocol? And so they started to go into a direction which was wrong. And so at first on Discord, I started, not arguing, but talking to people, say, you shouldn't do that to interact with the protocol. You shouldn't generate an account or an address like this and so on. And then at some point I was like, instead of spending, 3 hours a day discussing on what is needed for StarkNet, let's actually build it. And so I discussed with Itamar Gerald. I say, I think StarkNet is really growing fast. It's becoming at a point where it's very interesting and we can do stuff there. And there's basically no wallet. So it's a great opportunity for us to be first movers. And so I started writing the first version of our L2 account in Cairo. And to come back to your initial question, yes, Cairo is a new language. But again, when I started in 2017, Solidity was a new language to me. Learning a new language is not that complicated. I think people focus way too much on bringing the existing to new domains where we are still very, very early. The majority of developers haven't programmed anything in the blockchain space. So if you tell them start or Solidity or start or Cairo, in the end, they don't care. The learning curve will be exactly the same. Of course, Cairo was a bit less mature than it is today. And I think it's still a bit immature and it's still evolving, evolving well. So yes, it was fun at first. I enjoyed again, playing and discovering a new language and experimenting with something new. I think, if I remember correctly, I'm one of the first developers who actually deployed a contract on your testnet. I remember sending that to either Tom or to Louis, and that was very exciting. Actually, I wrote a smart contract. I deployed it on that new blockchain, and it works. So that was very, very exciting. So, but unrelated to that, I do think that you need to choose the best tool for the job. And I think in a zk environment, Solidity is not the best tool for the job. So it makes sense to write a new language. And again, I think it's the Starkware approach. Start from the foundation, build everything, but build it together with the community, which means that you are building it right. So it's very exciting. And over the past 6 or 7 months, Cairo has changed a lot already. I think every new version, it's much simpler from a developer's point of view. I think there's all the learning curve of Solidity also. So I kind of feel that it's like watching the evolution of Solidity, but in a contracted time, in a sense, you're evolving much faster.
We do stand on the shoulders of giants. When Solidity first came up, there was no such thing as a smart contract language or even best practices regarding what smart contracts are. And we have the benefit of looking 6 years or 7 years back in time and knowing, oh yeah, eventually they needed this, eventually this feature was important, eventually this tool was important, and we get to have a fast track to these. We know exactly what's missing in some aspects. For
Exactly.
some other stuff, it's much more difficult because these things don't exist in Solidity. Like one thing that comes to mind is like handling L1 to L2 messages, and both the syntax, and the cinematics around that and the tooling around that is very lacking. But for all the other stuff that you would want to do on Solidity, we have the benefit of hindsight.
Yeah, exactly. And again, you're seeing the same thing, right? I think when I started on Solidity, there was no strings, for example. And then someone built a library, and then everybody started using that library, and then that library moved to the language and is now part of Solidity. And I think you will see the same evolution, but it's much faster on K-Road. There will be people building libraries for certain higher level objects that are not there. And as more people start to use them, I think they will be incorporated into K-Road.
Yeah, it's an interesting process. I mean, like developing a new language and as you mentioned, building it with a community. It's a really interesting process, and building it with a community helps you make sure that things go in the right direction. At the same time, the more your community grow and the more there is inertia when you want to introduce new change. Like when you think about how much StarkNet has changed in the past year, sometimes it's really like impressive to see all the things the developers went through to actually make it work. Like a lot of things I changed. You remember selfie contracts when you couldn't get the contract, the address of the contract you were writing in, and you had to write a specific smart contract that would just return who called in.
That's true.
Anyway.
Yeah. I mean, it continues like that. You just upgraded on testnet to 0.10.0. And so I started last week, migrating our contracts. Migrating the contract was fine, but actually migrating the testing framework was a nightmare because all your testing objects have changed. And of course, it's very early. It was just pushed to integration. There's no documentation. And so I ended up having to rewrite some core function of our testing framework and browsing to all like the K-Roll and GitHub to trying to understand, and then ping Jonathan or ping Tom or Ariel to say, I'm stuck with this, what am I supposed to do? So yes, of course, it adds a little bit of overhead, because if the network changes, the protocol changes, or the language changes, you need to adapt. But I do think there's a lot of benefit. And one of them is that you can actually craft the platform in a way that matters to you. And a good example of that is, again, with this 0.10.0. When I finally managed to update my testing framework, I noticed that one of the tests was broken because of the new validate method, because of the constraint of the validate method. Then it turns out that what you had implemented was actually too strict. And so I ping Tom and I say, no, this has broken this and that feature. I think it's important. And I don't see any reason to do that. And Tom was like, okay, let me talk to the engineer. We'll try to chip that in. And it's actually on the release that you made on testnet. So I think being early, of course, it requires a bit more effort, but there's tremendous value of being in that position as well.
Yeah, and it's really a positive sum game. It's really cool to have like both insight from builders resonate with how engineers work and build a better product together. I think it's a beautiful thing to see. Specific question: when you code, how do you focus? Do you listen to music? Do you have a ritual when you're coding, or just like silently coding?
So it's a good question. It's probably one of my frustration, because being a founder in a company, you have a lot of stuff to do. And so I have little time to code. And usually when I want to dedicate time to code, I receive like 15 different, Slack, Discord, Telegram notification asking me, this and that. And so it's very hard for me to find time to code. And when I code, I like to have at least half a day. I don't want to code like 30 minutes here, 30 minutes there. It's more, I've been thinking about something all night. In the morning, I want 4 hours to actually see how that ID can go through. So it depends. if I need to focus, I probably try to listen to some soft music. That does help.
What kind of soft music? Like ambient, classical, lo-fi?
It's really weird, but I found out that listening to Nora Jones is actually a good way for me to focus.
Really nice.
It's not like I'm a huge fan or I never listen to Nora Jones outside of when I need to code. But I find her music, exactly, her music is actually is working for me. But so yes, so yeah, usually I need quiet time. I need to be focused and I need to be not distracted. And I have a short attention span, and so working from home in front of a computer where you can have access to millions different things. It's sometimes hard for me to focus and stay in that concentration for a few hours.
Nice, cool. Thanks, Julien. Look, we've talked about a lot of stuff. Thank you a lot for talking with me today. I think it was really interesting. There's a lot of fascinating topic, and I really loved your explanation on that. So thank you for that. Anything you want to mention? No,
I enjoyed the chat a lot. Keep up the good work, and excited for the future of StarkNet for sure.
Very nice. Cool. Thank you, Julien.
Thank you, Henri.
Bye.
Bye.